Hey, so what type of triangle is that? Besides a right triangle, what else do you notice? Not equilateral. Isosceles, because it has two congruent sides. An isosceles triangle, isosceles right triangle is a 45, 45, 90 triangle. So if this side's 1, what's this leg? 1, and the hypotenuse would be square root of 2. Okay? Now, let's say I want my hypotenuse to be 1 of a 45, 45, 90 triangle. If I want my hypotenuse to be 1, what happens to the two legs? I have to do what? If I divide this by the square root of 2 to get down to 1, what do I have to do to the two legs? Divide by the square root of 2. Can I leave them as 1 over square root of 2? No, so you have to multiply top and bottom by square root of 2. So they are square root of 2 over 2. Okay? Good with that? Okay. So we got a 30, 60, 90 triangle. If the short leg is 1, what's the long leg in a 30, 60, 90? Square root of 3. Thank you. And the hypotenuse would be 2. So let's say I want my hypotenuse to be 1. What do I do to the other two legs? If I want my hypotenuse to be 1, what do I have to do to my other two legs? Divide them by 2. So this is 1/2 and square root of 3 over 2. Why is that important? Well, in trig, if I want to know the sine of a 60-degree angle, okay, where this is 60 degrees, the sine is the opposite side over the hypotenuse, right? Well, if the opposite side is square root of 3 over 2, if you put that over 1, it's just square root of 3 over 2. So sine of 60 degrees is just basically the opposite side. When your hypotenuse is 1, it makes everything so much simpler, okay? So in a 45-degree angle, the sine is square root of 2 over 2. The cosine is square root of 2 over 2. Life is easy, right? If we only had a diagram to help us out with all that. There's this thing called the unit circle. What's a unit circle? Well, it's a circle with a radius of 1. Why is the radius 1? Because every triangle that you make with it will then have a hypotenuse of 1. If it has a hypotenuse of 1, then the opposite side will always be the sine and the adjacent side will always be the cosine. Maggie, are you doing trig or are you messing around with other stuff? Okay. So, if your hypotenuse is 1, so what this does basically is this. Whatever the x value is on a point of the unit circle, it's the cosine because x is left or right, right? So it would be the cosine, it'd be the adjacent side of your triangle. Whatever the y is would be the sine on the unit circle. What would be the tangent? What is tangent? Well, tangent is opposite over adjacent, right? Okay, I should draw it over here. What's the opposite side? The 1/2 or the square root of 3 over 2? From this angle right here. What's the opposite side? Square root of 3 over 2. It's the y value, right? So the tangent on your unit circle is going to be y over x. Is tangent. Okay? Then 1 over x will be your secant. 1 over y will be your cosecant. And x over y will be your cotangent. Okay? That's how to read a unit circle. So, let's say I wanted the sine of 150 degrees. Well, you look at 150 degrees. Sine is the y value. The sine of 150 degrees is 1/2. Let's say you wanted the cosecant, nope, the secant of 5 pi over 3. The secant of 5 pi over 3. And you go, what? Mr. Bierschbach, don't do this to me. Oh, this is not that bad. You find 5 pi over 3. Secant is 1 over x, right? So you take 1 over the x value. 1 over 1/2 is the same as if you multiply top and bottom by its reciprocal. Those cancel. It's 2, because the reciprocal of 1/2 is 2, right? So the secant of 5 pi over 3 is 2. If you only had your own unit circle to look at while doing this, it would make life easier, right? Oh! Should Mr. Bierschbach give you your own unit circle? Now, if you could only write on this, it would make it easier. Too bad. The only thing you can write on your unit circles is your name. You are not, and I repeat, you are not allowed to write on any of your unit circles because you get to use these on quizzes and tests. So the only thing you can write on them is your name. You have to know in your mind that x is cosine, y is sine, y over x is tangent, and so on. That you have to know. What?
Why do you have to know that?
You have to know it because that's part of trig class. It's the learning part. Because when you get to AP calculus next year, when Spencer goes to AP calculus next year, okay. So when Spencer's in AP calculus next year, he's going to be expected to remember trig functions and all trig identities and all kinds of stuff, because we've already hit trig identities in AP calculus already this year. So, there's plenty of you that could take AP calculus next year. I see multiple people in here.
Do you take AP?
I teach AP Calc. Yes. Okay. So let's look at a few of these. The cosine of negative 180 degrees. Well, looking at your unit circle, if 180 degrees is there, where's negative 180 degrees? Right, the same exact place. You're just going the opposite way around. So if it's a cosine, it's the x value. What's the x value at negative 180? Negative 1. Is it negative 1 because that's a negative? No, it's a negative 1 just because where it's located. The sine of negative pi over 6. Where's negative pi over 6? Well, it's right about here-ish. Okay, because you go this way, pi over 6. So if you're looking for the sine, it's the y value. What's the y value at negative pi over 6? Negative 1/2. Easy peasy lemon squeezy. I'm sorry, Taylor. There's tissues on my desk. All right. The cosine of pi. Where's pi at on your unit circle? How many degrees? 180. So we were looking for the cosine at 180. What's the x value at 180? There you go. Easy peasy lemon squeezy. All right. Hey. What?
Where is negative 5 over 6?
Negative pi over 6, not negative 5 over 6. Negative pi over 6.
Where pi over 6 is, and then just go the opposite way.
Right. Go. So look where pi over 6 is. It's 30 degrees up. So a negative pi over 6 would be 30 degrees down.
Okay, and would the x value change to a negative 3 over?
Pi over 6 is 30 degrees up. So from here, you just go 30 degrees down. It's right there. No, you don't. You don't.
I was just gonna mark my
Okay, hey, we've got plenty of example problems to go through. So this is all right. You know, you don't all need to cry. It'll be all right. Cotangent at negative pi. Where is negative pi? At 180, the same place pi is at. So we're over here. Okay, cotangent. What is cotangent? X over y. Your x value is negative 1. Your y value is 0. What's negative 1 divided by 0? Don't say 0! Life is really, really good until somebody goes ahead and divides by 0. Don't ever divide by 0 and say it's 0. It's undefined. I should get a shirt and say life is all good and well until somebody divides by 0. Yeah. All right. So you cannot divide by 0. It's undefined. All right. Boy, this is being recorded. It'll be interesting to rewatch this one. All right. Cosecant of negative 3 pi over 2. Okay. Normal 3 pi over 2 is right to there, right? So if we're going at a negative 3 pi over 2, we go boom, right there. What's the same place as negative 3 pi over 2? Pi over 2, which is the same as how many degrees? 90 degrees. We're at the 90 degree mark on your unit circle right here. Okay, so we're right there. We're doing cosecant. Cosecant is what? 1 over y. 1 over the y value, because it's 1 over the sine. Okay? What's the y value at 90 degrees? 1. What's 1 divided by 1? Thank you. Very good. It is negative 270, sweetheart. It's negative 270, which is in the same place as 90. There you go. Okay. We are caught up now. All right. Secant of pi over 6. Where in the heck is pi over 6? 30 degrees, first quadrant right there. Secant is 1 over x. Secant is 1 over x. So it's 1 over square root of 3 over 2. Uh-oh. When you have 1 over it, you just basically have to take the reciprocal of the denominator, which is 2 over square root of 3. Do the math gods like that? No. We have to multiply top and bottom by square root of 3 over square root of 3. So it's 2 square root of 3 over 3. That one's a little uglier. Okay? All right. Cosine of negative 2 pi over 3. Where in the heck is negative 2 pi over 3? Because normal 2 pi over 3 is down here, right? Oh, Mr. Bierschbach messed up. Normal 2 pi over 3 is right there. So negative 2 pi over 3 would be right here at 240. Okay? 240 is more like this-ish. Okay. All right. Cosine is the what value? X value. What is the x value at 240 degrees? Okay. Hopefully, some of you are starting to catch on. The others, hopefully, you'll catch on in the next 5 minutes. The sine of 225. Well, this is easy. Where's 225? What quadrant? Third quadrant. What's a sine at 225? The y.
Negative square root of 2 over 2.
There you go. Tangent of negative 3 pi over 4. Where's negative 3 pi over 4? What quadrant? Third quadrant. It's right here. Same as 225 degrees, right? Okay. So the tangent is y over x. So we have negative square root of 2 over 2 over negative square root of 2 over 2. When they're the exact same thing, it is 1. Okay, 3 pi over 4 is in quadrant 2, but this says negative. So you have to go this direction, that same distance. No, not straight across. You got to go that distance that you traveled. So 3 pi over 4, you went 225 degrees around. Because you always start from here. So you got to go 225 degrees backwards. You always start at the positive x-axis. Okay, so we've got it figured out now. All right, pi over 3. Where's pi over 3 at? 60 degrees, first quadrant. Secant is 1 over x. What's 1 over 1/2? 2. 1 over 1/2 is 2. So the cosine is 60 degrees. What is cosine 60 degrees? One half. Okay, we're at the same place. Now we're just taking the cosine, which is 1/2. Sine of negative 120. Well, 120 is right here. So negative 120 is 240. What's a sine at 240 degrees? Are we good enough with those? Can we skip a few now?
Yes.
Okay. We're going to skip down to here. Oh, don't worry. This is not that hard. When we have pi over 2 plus pi over 4, if we're adding them together, we need a common denominator. So the common denominator would be 4. So we multiply each of these by 2. So it's 2 pi over 4 plus 1 pi over 4 is 3 pi over 4. What's the sine at 3 pi over 4? Well, you go around to 3 pi over 4, find the y value, and you get Yep. What she said. We can make pi over 2 into 90 degrees. We can make pi over 4 into 45 degrees, add them together, so it's a sine of 135 degrees, and just do that. You know what? Your calculator ain't going to give you square root 2 over 2. It's going to give you 0.8660. No, some other decimal. Yeah. 0.8660 is square root of 3 over 2. Sorry. All right. Now, Chloe, when we get to number 18, can do her happy dance. Why? Because when we're rounding to 4 decimal places, it's actually telling you, put it in your calculator. Find the sine of 35 degrees. What is the sine of 35 degrees?
-0.429.
Oh, Chloe. Now, I'm glad Chloe gave that answer. 0.5736. Okay. What in the heck? Why in the heck would Chloe give a negative answer? Because her calculator's in radian format. So you all need to check your calculators and make sure they're in degree format. On your little TI 34s, it should say DEG. On your TI 84s, the big yellow ones, it's mode at the top, and then you scroll down to where it says degrees or radians. You scroll to on top of degrees and press enter, and then you're in degree mode. And you go second quit. Second whatever to quit out of there. And then do the sine of 35 and 0.5736. Okay, so everybody's in the right mode. So to do these, you just punch them into your calculator. We're not going to do a bunch of these because that's just boring. All right. Uh-oh. Uh-oh. Oh, no. What do we do when we have 59 degrees, 18 minutes? Does your calculator do degrees, minutes, seconds? It does, but you have to go through a process. So what's easier? 18 divided by 60, young lady. So it's 59.3, right? 59.3. Now Taylor's going, how do you get cosecant? What is cosecant? 1 over sine. So it's 1 over the sine of 59.3 degrees. Or you take the sine of 59.3 and you do the reciprocal of it. But I think 1 divided by the sine of 59.3 works just fine. What do you get when you do that? 1.1160 or 163? Oh, 1630, right? Round to 4 decimal places, 1.1630. Yeah, there we go. Let's do one more. The sine of negative 7/8. The sine of what? Okay. The sine of an angle equals negative 7/8. What would the cosecant of that angle be? Oh, no calculators on this one. No looking at the unit circle on this one. This is brain stuff. Maggie, explain it.
Oh, it's
Oh, yeah.
Okay, so that's y, because the sine equals y.
Sine is y.
And you gotta put, whatever that is.
Cosecant is 1 over y.
Is 1 over y, and then, so you have 1 over negative 7/8, and then you have to flip it. You can't have that.
Yeah, it's just a reciprocal. So sine and cosecant are reciprocal functions, so you just flip over the fraction. Okay? And the last one that you're going to see. If the sine is positive and the cosine is positive, what quadrant are you going to be in? 1. If the sine is negative and the cosine is positive, what quadrant are you going to be in? No. 4. If the sine is negative and the cosine is positive, how do you look at it? Well, when the y's are negative and the x's are positive, that's what quadrant you're in. Okay, quadrant 4. How about when the sine is negative and the cosine is negative? What quadrant are you in? 3. So in quadrant 2, the sine is positive and the cosine is negative. Okay, so I will assign out your second assignment now.